Hello everyone. In this video, we are going to discuss how we can convert an ER model into relational model. That means how the ER model what? ER model is a conceptual diagram of the database. So that conceptual diagram or ER model, how it will be converted into the tables or the relations in the relational model. That only we are going to check now, or we are going to check the algorithms or the steps how we can convert an ER model or ER diagram into the relational model. So let us consider there is an ER diagram, and with that ER diagram example, I will show you how we are converting into the relational model. So in this video, I am taking the example of a company database. Normally, in everywhere we are taking a company database that will be very easy and well known. So I think that will be helpful for easy understanding of how we can convert an ER model into the relational data model. So I will share the screen first. Okay, so ER model means entity relationship model. So ER to relational mapping only we are going to study in this video. There are 7-step process actually. The first step is map the regular entity types. Regular entity means the strong entity. So every database or the ER diagram will contain the strong entities and the weak entities. So first, what is the thing? We have to map the strong entity or the regular entity into the relational model. Then the second step is we have to find out what is the weak entity in that ER diagram. Then we have to convert the weak entity into the relational model. Then the third algorithm or the third step is what? Mapping the binary one-to-one relation type. So normally in the ER diagram representation itself, we will draw the relationship between the each entities, correct? So there are different types of relationships are there: one-to-one relationship, one-to-many relationship, and many-to-many relationship. So first here we are taking the one-to-one relationship type and we are converting it into the relational model. Then next we are going to check the one-to-many relationship. Which are the entities having the one-to-many relationship? Then that relationship we will be converting into the relational model. Then many-to-many relationship we will convert. And after the conversion of all these three type of relationship, then only we will go for the multi-valued attributes. Suppose I will tell you, maybe you will be a confusion about what is this multi-valued attribute. See, in a table, suppose I'm going to say the branches of a company. Okay, I'm going to take the example of a company only to convert the ER diagram into the relational model. So I will tell you an example in the company itself. So the company database and a company will have different branches in, suppose in Karnataka itself, they will have different branches in different places. So if we are writing the location of a company, what will happen? The branch will be, or the location may show multiple values. Maybe your Hebbal, maybe Madiwala or Silbod, like that many different places it will show. So that is known as multi-valued attribute. That means in a company database or a company table, there is a column is exists. That column name is location or the place of the company. In that particular column or in one cell or one record itself, they are storing multiple values like what 3 cities or 3 places details. That is known as, or that particular column or that particular attribute of that table is known as what? Multi-valued attribute. Okay. Then next one or the last step of the conversion, what is that? mapping of n-array relationship types. Normally in our tables and all, this n-array is not exist, but in some cases n-array relationship also there. So if it is available in n-array relationship, then that also we have to map at the end, or the finally the mapping of n-array relationship types only taking place. Okay, so we are moving to the examples. See, this is an ER diagram. Okay, this is an ER diagram. You can see that one. Okay, I have taken the example of the company, and you can see that here there are one employee is an entity, and dependent is an entity, project is an entity, department is an entity. There are 4 different types of entities are there, and you can see that one, the employee and the department and the projects are what? Strong entities. How we are understanding this is all a strong entity? See, the strong entities will be represented by only one rectangle. The strong entities will be represented by the rectangle, but the weak entity in an ER diagram is represented by what? Double rectangle. So in this pictorial representation itself, we can easily identify that the dependent is a what is that? The dependent is a weak entity. Here it is. Okay, then here we can see that one, there are different types of relationships exist between the entities. You can see that one, the cardinality or the type of relationship is mentioned here between the entities. You can see that employee and the dependent table or the entities will have a 1 to n relationship. It is represented here before and after the that relationship. Okay, so like that, many are having different types of types of relationship. Okay, now again one more thing is that what is that multi-valued attribute, that also we have discussed in the steps, correct? Here, weak entity and strong entity, we find out what are the weak entities, what are the strong entities. Then different relationship also exists in that diagram. And then last 6th step is what? Multi-valued attribute. Okay, so you can see that one, how we will represent a multi-valued attribute. The multi-valued attribute will be represented by the double oval symbol. So here employee doesn't have any multi-valued attribute, but you can see that here a composite attribute is available. That means the name is again splitted up into what? F name, middle name, last name. Okay, that is available, but this name is not a multi-valued attribute. But the department, you can see that the department has a multi-valued attribute. You can see that location, the location is represented within a double oval symbol. So what is that? That is a multi-valued attribute. Okay, so that also there is a method, or there is a there is an algorithm or a step is there to convert the multi-valued attribute into the relational model. Okay, so now we are going to start one by one mapping. Okay, so this is the pictorial representation of the ER model. This only we are going to take as an example. Okay, so what will be the first step? Mapping of regular entity type. That means we have to map the strong entity type from the ER diagram. What is that ER diagram? We have company ER diagram. From the company ER diagram, we have to find out which one are which are the strong entities. So from the example itself, we can see employee is a strong entity, department is a strong entity, project is a strong entity, but the dependent is not a strong entity, it is a weak entity. So as a first step, what is the first step? We have to convert the strong entity into relation. Okay, so what will happen? we will create a table of employee, and all these employee will have columns, birth date, SSN number. Then this name we will be dividing, and we are taking only first name, middle name, and the last name. Then sex, address, and salary. These will be the columns of the table employee. Okay, I will. So the same way we have to convert department and the project. And one thing is there, in the department, we will not consider the location. Location is a what multi-valued attribute. So in the first step, we will not convert this multi-valued attribute into the relational model. We will omit, or we will be putting it in the waiting state, and we will use only the name and number for the department table as an attributes in the first stage. Okay. So I will show you here. See, this is how we will get three tables. The first table employee, or a first relation employee. Employee will have first name, last name, middle name, and sex, address, salary, SSN, and birth date. You can see that one. SSN is the primary key. How you are understanding SSN will be a primary key? The primary key in the ER diagram will be represented by the underline. See here, this SSN is represented by a, or it is underlined. That means that will be the primary key of that entity employee. So we will consider it as a primary key here in the relation itself. Okay, this will be the primary key. Okay. Then second table is department. Department what have name and number, name and number and location. But what is happening here in the department? I will show you once again the ER diagram. You can see department location will be multi-valued attribute. So now we are not considering this. Only we will consider, or we will take name and number to convert into the relation model. Okay, you can see that department is taken name and number only, and project name, number, and location we have taken. Here you will get a doubt like that. Here we have taken the location for the project table. Why we didn't take the in the department? Here this location is not a multi-valued attribute. This is the normal attribute. Only one value only going to store inside this location attribute. So that's why we are taking here to convert into the relational model. Okay, if this location also multi-valued attribute means we will not take in this stage. Okay. Then the second step is we have to find out the weak entity and what we have to convert it into relational model. Okay. So did you know what is the difference between the weak entity and the strong entity? Strong entity means what? They will have a primary key to uniquely identify their records in the tables. Okay. But in the weak entity, there is no primary key. It will be dependent on any other entity, any other strong entity. It will not, weak entities will not have any primary key to uniquely identify their records. Okay. So in this example, we have what? We have one weak entity that is dependent. See, that is dependent. Dependent is the weak entity in our ER diagram. Okay. So this weak entity is depending on where the employee table. Okay. So that will be the second one. You can see here in this ER model, we are converting. What is the second step? We are converting the weak entity also into the relational model. So earlier we got three tables. What is employee relation, department relation, and the project relation. Now we are including, or we are converting the weak entity also. The weak entity name is what? Dependent. And the dependent has different types of what? Different types of values or attributes are also exist. What are the attributes for the dependent? Name, sex, birth date, and the relationship. You can see down. Okay. So that all are the what attributes of the dependent table that we will be writing. Okay. ESSN number, name, sex, birth date, relationship. And you can see that the dependent table will be, or the weak entity will be depending on the strong entity. Here, as per our ER diagram, the weak entity dependent entity or the dependent will be depending upon the entity employee. Okay, so what will be the meaning? So the primary key of the employee relation will be taken into the dependent table as a foreign key. Okay, so here we are taking, this is what this ESSN number, actually here it is a what foreign key and this is related, or we are dependent on the primary key of the employee table. Okay, this is how we are converting the weak entity into the relational model. Okay, then next one, step 3, mapping of the relationship. The first relationship is one-to-one relationship. So for each binary one-to-one relationship type, are in each ER schema, identify the relations S and the T that corresponds to the entity types participating in R. Choose one of the relations, say S, and include a foreign key in S, the primary key of T. That means one-to-one relationship. So suppose S and T are the two entities in the ER diagram. Then S and T, between this S and T, only one-to-one relationship is exists, means what will happen? The primary key of one table will be taken as a foreign key into the other table. Okay, I will show you here, which are having one-to-one relationship here. Employee, managers, department. This table has only one-to-one relationship. You can see that it is mapped here, or it is written here, one-to-one, and there is a what? There is a descriptive attribute is available. What is descriptive attribute? Descriptive attribute is nothing but any attribute is available for a relationship, then that is known as descriptive attribute. Okay, so we'll see how it is mapped. You can see here that department and the department managers, correct? Department managers employee and department table has one-one relationship. So you can see here department table. What is the difference? I told you one-to-one relationship is exists between any two entities in a ER diagram. Then from the first entity, we can take the primary key and we can use as a foreign key in the second table. So in this example, employee will be the first entity and the department will be the second entity. This between the employee and department, one-to-one relationship exists. So the primary key of the first table or the first entity, that is what? Employee. Employee table has what? Primary key SSN. That primary key will be taken into the department table as a foreign key. Okay, so it is written here manager SSN. And one more thing we will add, if it is there is any descriptive attribute is available for a relationship, then that attribute also will be added into the second table. You understanding? See here, the employee and the department tables or the entities having a one-to-one relationship. Okay, and that relationship also having one descriptive attribute. So what will happen? From the first table, that is employee, what will be the primary key of the first table? That primary key will be stored into the second table as a foreign key, plus the descriptive attribute also will be stored into the second table. That only happening here. You can see in the department table already name and number is existing. With that, we are adding the SSN, manager SSN. That means this is the primary key from the employee table we are taking, and we are adding the descriptive attribute also. Start date is the descriptive attribute that we are going to add here. Clear? That only the one-to-one mapping. Then the second one is what? One-to-n mapping. How we can convert or map a binary one-to-n relationship into the relational model. Nothing. Here also you can see include as foreign key in S, the primary key of the relation T that represents the other entity type participating. That means what is happening? No, from 1 to n, where is 1 is coming from 1, where is 1 is coming, that means cardinality 1 where it is written. From that entity, we are taking the primary key and we are storing into the n where it is written. In that entity, we are adding into the foreign key. I will show you in the example, then you will get more idea about that. 1 to n is, see, employee works for department, that is 1 to n, and 1 to n is this also, employee depends of n, dependent. You can see that what is the changes happened here. The primary key is added into the department. It's already mapped, so that's why we are not having any other things. See, department, you can see here the department number. See, the department number will be the primary key of the department table, and you can see that one from the example where, see, employee table and the department table having a 1 to n relationship, correct? So where is 1 is coming, or which entity side the notation 1 is coming, from there we will take the primary key and we will add that primary key into the second table where n is coming. Okay, where n notation is coming, into that table we will add the primary key as a foreign key. So what will be the primary key here in the department side? The number will be, number is the primary key. So this primary key, department number or department number is the primary key of the department table, that will be taken into the employee table as a foreign key. You can see here department number is added into the employee table as a foreign key. This is referring which table? Department table number. This is the primary key of this department table. So only we have to remember that from one side where the notation 1 is coming, from that table we will take the primary key, and where the notation n is coming, or n is where n is written, into that table we will add or we will insert that primary key as a foreign key. Okay, then next one is mapping of binary m to n relationship type. That means we are going to convert the many to many relationship type. Okay, so we'll see where is the many to many relationship type is there. See, employee and the project having many to many relationship. So what happened to our employee table and the employee table and the project table? See, if there is a many to many relationship exists, we cannot take the primary key and we cannot add into any other table. Only one option is available to convert the many to many relationship into the relational data model. That is what? To create a new table for the relationship. Okay, so here one relationship is available, works on. So for this relationship we are converting, or this relationship we will be converting as a new table. So in our relational model we will get a new table. You can see that works on, that is a new table, and that works on relationship having a what descriptive attribute, that is ours. So with this descriptive attribute, we will add the primary key of employee and the primary key of the project. Okay, project table. So we can see that works on, that particular relationship we have converted into a table. So this is a table, and what are the attributes of the table or columns of the table? So already that works on having a descriptive attribute, that is hours, how many number of hours that employees should work on that project. Okay, so that hours will be a descriptive attribute that will be added, plus or apart that what we have, the primary key from this entity and the primary key from this project entity. Okay, so that we are adding as a what attributes of the table works on. Okay, now the last sixth step is mapping of multi-valued attribute. So in the earlier step itself, we have what avoided or omitted that attribute, multi-valued attribute, that is location. Now there we are going to take that location. What we will do, how we will do that location? Only one way. See, you can see that department table only having one multi-valued attribute, that is location. How we will convert that location into the relational model. Okay, where that location is available in the department, correct? For this multi-valued attribute, how we will convert? We can create a new table with because in the location we will have different values, correct? Maybe Delhi, Bombay, or from ETCs we are checking from the Karnataka state itself. Then maybe Hebbal, Silbod, Madiwala, Hennur, many places will be there. So different values we are going to store. So that is not possible in the tables. That as per the normalization, the first table itself, it should handle or it should store only atomic values. So we should have, or we should normalize the table. So atomic values only we can store inside the table. So only one way we can create a new table to store all the locations. Okay, that's what happened here. You can see that department location. One more table we are created, and the location, that value attribute we have added into the table. Plus we have to uniquely identify, we are telling about the locations of what departments, different departments, or suppose say that different branches are available. So the branch ID will be there, or the department ID will be there, correct? So with the department ID only we can uniquely identify what are the locations of that particular department or particular branch. That's why we are going to take here what department number from the department table. Okay, so earlier we had only 4 entities, but after converting it into the relational model, we got how many? 6 tables. Okay, and the last step is what? Mapping of n-array relationship type. See, normally this n-array relationship is not coming in our examples, but suppose if it is coming, n-array is coming, what we can do? Okay, so for each n-array relationship type R, where n, the relationship is greater than 2, create a new relationship S to represent R. Okay, include as foreign key attributes in S the primary keys of the relations that represent the participating entity types. Here we are giving an example. Okay, supplier, project, and part are the entities, and you can see that one more than 2 relationship exists between these things, correct? So while creating, anyway, while converting itself, we will get 3 tables or 3 relations. One is supplier, one is part, one is project, correct? Supplier, project, and part. Upon that, for this n-array relationship is there, correct? A relation is available. For this particular relation, we will create a new table, and it will have what? The descriptive attribute as one column, plus with the descriptive attribute column, we will take all the primary keys of the different tables. The supplier table will have a primary key that will also added into the last table. And the project also will have a primary key that will also added to the last table or newly created table. And the part, this entity will have a primary key that also will be added to the last one. You can see here supplier having more number of columns. The last one, supply. You can see that one. See, supply table. Supply table means what? That is a relationship only, correct? That is a relationship apart from supplier table, part table, and project table. We are creating the table for a relationship. If the relationship is more than 2, that means another relationship is exist in the ER diagram. Okay. So for that relationship, we will create a new table, and if there is a descriptive attribute is available, then we will add it as a column. Then plus we will add all the primary keys of the related tables. Here 3 related tables are there. We will take the primary key of that particular tables and will create a new table. Okay, this is how we are converting the ER diagram into the relational data model. This is very easy thing actually. So once again, I will conclude. First, what we are finding out? We are finding out the strong entity. Then the strong entities we are converting into the relational model. Then we will find out the weak entity from the ER diagram. Then we will convert it into a relation, and we will add the primary key of the strong entity to whom it is dependent. Okay. And then the third one is one-to-one relationship. We have to convert into the relational data model. Then one-to-many and many-to-many. After all these relationship, we are going for to convert the multi-valued attribute. The multi-valued attribute, we can create a new table for the multi-valued attribute and can give the primary key. We can take the primary key from the table and we can give us a foreign key here in the newly created table. Then the last one is how we can do the n-array relationship, or how we can convert the n-array relationship. Nothing. For n-array also we are creating a new table and we are taking the primary keys from all other related tables. Okay, this is how we are doing the conversion of ER diagram into the relational data model. Hope you are understand. If you want extra, or if you want to get more information about this concept, you can go and check the book Database Management System, 3rd edition, Ramakrishnan Gherke. You will get more idea about this. I hope this video is useful to you. Thank you so much.